Hi, so in this video we're going to cover some of the more basic kind of features, functional features of cosine of t and sine of t. Um, and the thing we want to keep in mind while going through these is, they all correspond to the fact that cosine is how far forward and back your position is as you move around the circle, and sine is how far up and down you are on the unit circle as you move forward and back. All right, and so we're going to examine the domain and range, which are things we should ask of every single function um, the moment we define them. Um, you know, what things can you put into the function? Can you evaluate it at? What sort of outputs are possible? And then, because these are circular functions, we have some of our properties of circular functions to example, like the midline, the amplitude, and the period. All right, so let's take a look at cosine here. Um, so the domain in this case is how far forward or back you can move along the circle. And the fact is that you can move as forward as many times as you want, right? As much as you want. There's no limit to how far forward you can move back. There's no limit to how small forward you can move. But you can also go backwards, right? You can also go the other direction. And if you go counterclockwise, there's also no limit to how far forward or back you can go. And so the domain of cosine is minus infinity to infinity, or all real numbers, because you can go forward any distance you feel like, back any distance you feel like, and that's all fine. Now, as far as the range go, the range is how far forward or back you are in the circle as you move. Well, you can only be so far forward, right? You can only be because the circle is radius 1, you can't just go anywhere you want, right? You can only be uh, at the rightmost point 1 unit to the right, and at the leftmost point 1 unit to the left. And so the range of cosine of t is minus 1 to 1, right? The biggest your x value could be is 1. The smallest it could be is negative 1. I can't go past that because then my distance from the origin is more than 1, and I'm not on the unit circle anymore. Now, as far as the midline goes, if we take a look, zoom in a bit on our function here, right? I'm going up to 1, I'm going down to negative 1, right? We have our range there. And so that tells us our midline should be in between those values, or 0, right? Let me plot a y equals 0 real quick. Let me dash it because I like that. Then, right, you can see that's exactly in the middle of my peaks and valleys, right? So a midline of y equals 0 is what makes sense there. And then the amplitude is how far up and how far down you go from your midline. And again, we know we're going all the way up to 1 and all the way down to negative 1. So that gives us an amplitude of 1, right? We can see that this distance here is 1 and that this distance here is 1. Now, as far as the period goes, we can try to eyeball it from this picture here, but that's not really going to be that easy. The better way to think about it is, how far does it take for this thing to start repeating itself? Well, I start at 0, and I go up, 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 around, and when I've traveled a distance of 2 pi, the circumference of the circle, I'm back at my starting point, right? And so every 2 pi units, it repeats itself. And so from that, we can deduce that the period of the cosine function is 2 pi. And we can see this a little bit more concretely, maybe if I plot, let's say, the points. Let me draw 2 lines, x equals 0 and x equals 2 pi. Let's make them the same color and dashed, why don't we? Right, we see that, yep, from 0 to 2 pi, that's exactly a cycle, and we're back to where we started. And if I were to zoom out a bit and graph x equals 4 pi, then we can once again see that, yeah, that's the same thing, right? It repeats itself and repeats itself, because when you go around the circle, 2 pi is once around, 4 pi is another way around, 6 pi will be another way around. And if I were to go negatively, negative 2 pi, negative 4 pi, negative 6 pi would be the same thing, right? All right, so that's it for cosine. And so now let's turn our attention to sine. But if you think about the arguments we use to make the case for these values for cosine, they're not really any different for sine, right? I can go as far forward or back as I want. I'm going up and down. I can go as high up as 1 on top and negative 1 on the bottom. I can't go higher or lower, or I'm too far from the origin. Right? Let's throw sine up here. Alright, there we go. I'm still going up and down to negative 1, which means my midline is still 0, right? That's still in between my peaks and valleys. And then my amplitude is still 1. And I'm still moving around the same circle. So my values repeat themselves still every revolution around the circle, every 2 pi units, right? Every circumference. So we have that sine and cosine share all of these properties. They both have a domain that's any possible real number. The outputs range from negative 1 to 1, right? Because we're stuck on the unit circle. They both have midline 0. They both have amplitude 1 because your coordinates can only, whether it's x or y, can only differ by at most 1. And your period is 2 pi because every 2 pi units you start over and make another revolution. So they share those properties. Now, mind you, they're clearly not the same function. If I graph them side by side, there's different outputs for different inputs, for the same input rather. But, they don't have to be identical functions in order to share at least this list of properties. So, thank you for watching. If you have any questions or issues with any of this, please reply in the discussion board or an email, and I'll address them, and I will see you in the next video.